gained while in the college. He worked as a free design as a product designer for a community-based project which includes a block printing machine for amplitudes and aquaphonic systems for urban areas. His skill sets and area of interest are product design, automobile design, rapid prototyping, technology, and he is a technology enthusiastic. Okay. Both of them have together started a small startup entrepreneur that is STELNA Designs, and it was started in July 2020 at Mangalore, which offers an demand for manufacturing services with a focus on low volume manufacturing using 3D printing and allied technologies. So STELNA Designs are working in the area of 3D printing for hobby projects using open source designs, which leads us to conduct workshops in colleges on 3D printing. After graduating in ENC and in mechanical, both have combined together and they have started with their own potential to come up and realize the potentials of 3D printing to give service for the customers who are willing to this. And they are providing their service all over India, and just now they are providing service for MRPL and MCF in Bangalore also. So with this small and brief introduction, I would like to welcome both Suhas Kamath and Sumanth Shenoy for this FDP program.
Thank you, sir. Thank you, sir, for the introduction. Right now, Sumanth will do the first half of the presentation. I will come later on.
Okay. You can share your PPT presentation.
Got it. Screen not a share code option.
Yes, it's visible, but just to go for the full screen. Yes.
Hello.
Yes, yes.
Sir, am I audible?
Yes, very much clear.
Yeah, yeah. So, hello everyone. Actually, we were exploring a different topic since till yesterday. Then we were also attending this workshop, and we thought a lot of information is already being given. So instead of pumping some more information, it's better to share our journey and the observations and insights we have got throughout this journey of providing services to different industries and consumers using 3D printing and different technologies. So basically, to introduce about our company, we represent ourselves as on-demand manufacturing services and solutions. That means we want to provide different types of manufacturing services to wide variety of population, irrespective of the geographical location they are in and irrespective of the technical background they have. Since we were introduced to 3D printing since a long time, since we were in college, and we were working in the same field in one or other way, so we started with the focus on 3D printing and low volume manufacturing. So just to give an idea of why we started, what problem statements which made us to start this, in our previous stint in our career as working in different responsibilities as embedded systems or product designing engineers in agri-tech startup or mixed reality startups. Working at a startup means the human resources is less and the responsibility is more on each individual, and we are exposed more to the product designing, manufacturing aspects of the product. Normally, when an idea comes in, the first thing which we do is to build a proof of concept for the product. The proof of concept is just to check whether just to demonstrate the concept of the product, to check whether it works or not, to interact with the customers. The product, whatever you build need not be sturdy, need not be sellable, etc. But when the proof of concept is convincing, the next challenge is to build a product out of it. And that transition comes with a lot of challenges. Normally, in today's day, the normal process which is followed is proof of concept, MVP, then production run. Initially, a proof of concept is built, then a minimum viable product is built. A minimum viable product is a product which has minimum amount of functionalities, which can be called, which can be sold to the customer, and or which customer wants to pay to. So this can't be a jugaad kind of a product. This has to be in a presentable way, and this has to be sturdy. This has to be less bug free. This has to be as much as less bug free, etc. Basically, the idea of MVP is to check the waters and then further develop the product without investing much. So the characteristics of a MVP is it's low volume in nature. Even though it's low volume in nature, the complexity of the product, the complexity of the functionality, or the amount of effort which is needed to put in building this is not less than a actual production run. The scale is more in production run, the scale is less than MVP, but the amount of effort which is needed in terms of technical inputs, the human efforts, is more. So during the MVP process of the product building in the early startups which we worked in, and also based on the inputs from our friends from the industry, for a small scale startup or for a small and medium scale industry, the access to high quality prototyping tools was less, at least around 4 or 5 years back. Now the Karnataka government is started initiatives like common instrumentation facilities, etc., like KTech Innovation Hub, where they are pooling all kind of prototyping tools at one place and making it accessible to everyone. But still, the high quality prototyping tools, access to prototyping tools is less, at least at our disposal, physical access. Then manufacturing a low volume parts, if say for example we need a casing and injection molded, then going for injection molding will be very cost heavy. Then if you want to go for 3D printing, then the right process in 3D printing is necessary. Say if it's not possible in FTM, we have to go for SLS. Again, access to that becomes a problem. And if it comes to PCB or something else, having proper data of vendors who could fulfill the requirement is one challenge. And at the same time, as a startup, there will be lots of things to figure out during the manufacturing, which we might not be knowing. And the proper communication and information sharing between the industry and the potential customer who is a startup, that is lacking. And as a whole, this tier 2, tier 3 manufacturing sector, where it has potential to cater to the low volume needs of a startup, it's highly disorganized. So basically, with these problem statements, it kind of bugging us since a long time, and we were discussing and brainstorming a lot in this. And we were in touch with 3D printing since around 2014-15, and somehow with exposure to that technology and the ecosystem around it, and the exposure to the problem statements in the production, in the manufacturing process, somehow it came together and we thought of starting STELNA Designs. The exposure to 3D printing for us happened when we were discussing about building a RC car, and the kit for the same was costing around 3 lakh, 4 lakhs, which we couldn't afford. And we were active in maker communities on the Facebook, internet, etc. And we were aware that during 2014-15, a lot of people were building 3D printers out of open source kits provided by open source designs provided by RepRap, and so many kits were available. So me and Suhas thought, why not build a 3D printer and then build the parts for RC? We ended up building a 3D printer, but we didn't end up building a RC car. So this was a model of the 3D printer which we had built then in 2015, a very messed up form factor it was. It was breaking every now and then, but it was a result of a very amateur, enthusiastic engineering students in 2015. So since then, after exposure to the different aspects of manufacturing and the process, we thought, why not start up in this field in around 2019-20, and we started to speak with the potential customers, speak with the vendors in around 2019, and started to scout for the printers, started to scout for resources, etc. And design, thinking of an idea, thinking of setting up a process is one thing. Then setting up a business is a new whole ball game. And one of our friends' father, who is a CA, he helped us in regards to what are the basic things which are required and what is enough and what can be got used later, can be acquired later. Like every startup goes for private limited or LLP registration. Not every startup need to register for the same, can start as a proprietorship or partnership, etc. So in STELNA designs, the problems basically we are trying to tackle is reduce prototyping and manufacturing time, especially for a small and medium scale industries or startups, and cater to the low volume needs of the same, low volume needs of the complex geometrical parts also, and customized requirements of small and medium scale industries where there could be a machinery which they have imported from abroad, and the parts for the same, spare parts for the same might not be available, and customized parts might have to be designed and given to them, and make it accessible to everyone. This is the core point which we are trying to tackle. Like irrespective of the background the person has, irrespective of the contacts he has, irrespective of the exposure of the company which he represents, the manufacturing techniques must be as easy for an industry and must be as easy for a layman also if he wants to build a product. This is the long-term goal we are chasing. We are our aim is to build solutions and services in coming days which help us to achieve this target. So there are so we are as a company, we are not just targeting 3D printing, we are catering the needs across the 3D printing ecosystem, whether it's designing 3D printing services, educating the industries regarding the field, etc. So in 3D printing services, we provide services across all the major technologies like FDM, SLA, SLS, metal printing, etc. So this is something which, as I had touched earlier, different types of applications might be different types of technologies, and access to all those technologies might not be available in the maker spaces or incubation centers or the service providers. So access to all those technologies is one thing. And low volume manufacturing, the CAD model is the fuel to the 3D printing or manufacturing services these days. So product designing services and consultancy and use case analysis and 3D printability in a particular industry. The penetration of 3D printing, the possibilities of 3D printing is huge, but finding out what are the possibilities in an industry is a huge task. So that we are trying to do. And also we provide services of setting up additive manufacturing process setup, whether it's software, 3D printers, and the production process for industries or colleges, incubation centers, etc. So far, it has been almost a year since we have started, and we are fortunate enough to provide our services to both industry and consumers in different domains, like whether medical machinery, packaging and supply, variables, casting industry, sports performance technologies, etc. As we know, the 3D printing has lots of application in lots of domains, which are listed in the screen, and a lot of things have been already been explained in the workshop in last 4 days. Even we were attending it. So we will not explain much about the application specific parts in each domain, but we will share our insights in working in different domains and providing services in different domains. And Suhas will take over now.
So certain observations and views which we encountered during our operation period from the last 7 months, which were like the term called digital manufacturing. Like if a product has to be manufactured, we have to have a design or a mechanical drawing of the part. Then we have to make a CAD model, and the guy making the design and the CAD model doesn't have to worry about the manufacturing process. Then an engineer has to sit and analyze the given requirements or the design features or the surface finish of that part, and he has to plan for the manufacturing process. So this might be cumbersome, and it might take time for the product design time. And this thing is being solved by 3D printing and also in digital manufacturing, where the main advantage of the process is a person doesn't need to explain or give the features of the product. Instead, the file itself communicates with the machine. The file itself communicates with the machine, and it explains its features and plans. This is a revolution in terms of manufacturing technology, where transition from resources like mechanical drawings, explaining an engineer for the process to be chosen, to the resources itself communicating with the machine about its features and details. So 3D printing not only depends only on the machine, but there are processes involved before 3D printing and after 3D printing. So like softwares involved in designing and slicing of the models. Right now, currently softwares were used only for CAD designing, but the advent of 3D printing has made even the software manufacturers embed certain codes and features about 3D printing inside their design software itself, where it is easy to export a design file in the required format. And uh, the exported file also need to be kept in certain orientation, and required processes need to be done in terms of getting a good 3D print, depending on the application of the product. Then comes the machinery, where like choosing the right process of 3D printing to get the required part to be done according to the application required. And the monitoring softwares are also present, where you can monitor the real-time progress of the part, and if any changes are required, which can be done remotely. And distribution is also one of the main advantages of 3D printing. Like if a part has to be supplied in different countries, it need not be manufactured in one country and it has to be exported to that. Instead, a single digital file can be mailed or sent to the person who is in charge of manufacturing in some other place or some other country, where these processes can be done. So one of such open or free websites where you can get free CAD models is Thingiverse, which is mainly open source and community backed website, where various creators where various creators can upload their designs, and if someone has a 3D printer, he can use that website and get his models done. And these 3D, like the current FFF or FDM 3D printers were hugely fueled by the open source movements which were run from 2007 to 2014-15, where various creators or makers gave their knowledge on a website called RepRap, where people were sharing their designs of 3D printers, which helped in coming up of many OEMs in 3D printers. Like the boundary between the hardware and the software aspect of a product designing is fading away. And as they tell in IT industries, data is the new oil. It is not just in IT industry, it is also applicable for each and every industry, including manufacturing industries, where the manufacturing is being data driven in the current coming future. So here are some of the products which we came across or which we developed during our last 7 months. So we will share some of the insights about these products which we have made. So one of such is a customized gifting product which which a customer wanted. So one of the major application or advantages of 3D printing is increased customization, or each and every part can be iterative and customized according to the customer needs. If a person needs a low volume gifting part or any part of his choice, he doesn't know the processes to be taken care of, or he doesn't have any contacts of manufacturers to get his part done. So one such example was a product of this which is shown on screen, customized gifting, which was the client had seen the part on internet and he couldn't find that part in India, or that part was not available for sale in India. So he took the help of a website and he bought the files and he shared that files with us. So we were able to produce that part within a week and we had shipped him. So the main requirement will be like they have to have a part, but it also has to be of production grade. This was one of the learnings which we got from this application. And one more was 3D printing, which can help conventional manufacturing techniques like casting industry. So there are two images of gear. One is of a metal cast iron gear, and on the left you can see is a pattern for a gear. So the problem in manufacturing this gear was like we are currently explaining the problems faced in tier 2 tier 3 cities, as we are based out of here. So a casting industry had a problem of manufacturing a gear of diameter around a meter. So they didn't have tools to do gear tooth cutting. Either they had to make it done from Bangalore or some other place. So they thought of doing a casting of that gear. So they had various plans on how to cast the product itself. Then they had tried some processes like laser cutting and stacking the sheets of acrylic and making the casting pattern, but which didn't work out. So we were at the right time at the right place, and we explained how 3D printing can help casting industries and 3D printed cast patterns can help ease the process of pattern making. So we had discussed, and we came out with an with a solution, like we can split the gears in each part, and we printed the gear tooth itself, and which were joined to make a gear of the size of around 1 meter, 1 meter dia, and which was casted, and the cast was successful. These cast the problems in tier 2 or tier 3 cities are they have cast requirements of a very small scale, as they are not exposed to large volume casting production. Batches of small quantities will be produced here. So having a pattern made of wood, and the complexities involved will be more. So making a complex wood pattern would cost them more and needs a lot of explanation to the pattern vendor. So 3D printing is a self-explanatory, as the CAD model itself speaks with the requirement of the product, and the pattern is printed using a CAD model. So it has a potential to assist and exist with conventional manufacturing techniques for tier 2 and tier 3 cities. One of the major problems in small and medium scale industries in small cities are they have they are unorganized, but they have skilled laborers, and they have limited tools to cater for the opportunities they get. Like most of their products will have tight cost constraints, but with high complexity. So these kind of problems can be solved with the 3D printing, as these industries are not much advanced in technologies in terms of technical processes like 3D printing and advanced manufacturing processes. So introducing or explaining how 3D printing and such additive manufacturing processes can help them would be a major segment of market in the present scenario of Indian manufacturing. Then let us see how a design for additive manufacturing process can be done for an example part, where 3D printing like slicing is one of the major aspect on how the part quality should be obtained after the printing. So 3D printing is not just producing a CAD model, slicing it, and printing it in a 3D printer. Instead, planning of how the orientation of the product has to be done, like keeping in mind the application of the product, the geometry of the product, certain decisions have to be made on the orientation, the layer height, the support which needs to be given for the part, the infill of the part, the infill patterns of the part, which give various strength for the part in terms of the application which has to be done. So after 3D printing, there are some post processing needs to be done because the 3D printed part in a FDM or FFF doesn't have a finish like a injection molded part. So certain post processing has to be done in terms like if we have to give the part to a client, the client expectations have to be met. So for FDM 3D prints, sanding or grinding the surfaces has to be done, so that the surface finish of the part will be good, and for resin prints, the curing of the part can be done using UV light, and chemical treatment of acetone or isopropyl alcohol is used for smoothing the surfaces, and certain surface finishers and painting can also be used for the post processing depending on the application. So the one more major in terms of 3D printing is DFAM, or digital manufacturing for additive manufacturing. So 3D printing does not have career opportunities in just 3D printing. Like not just having a printer and printing part is not only the option, but 3D printing has various job roles, where major one will be the CAD modeling, and the part of slicing or the orientating the part is also becoming a major career option in 3D printing, where certain softwares are mainly built to have a good slicing features and all. So and post processing of 3D printed part is also booming. So career opportunities in post processing is also one of the major aspect for growth of 3D printed applications across the platform. And coming to STELNA designs, we plan to make digital manufacturing as easy for everyone in India. So accumulate not just 3D printing, but all allied manufacturing processes and take it online. So if anyone needs a part or a product remotely, he can upload or give information about that online, and which can be further processed. Right now we have that service available for 3D printing, where you can upload a file, and we can get it done according to your requirement and your priorities. So thank you for everyone, and Canara Engineering College and Department of Mechanical Engineering for giving us an opportunity for a small talk on the experiences we had and our learnings. So if anyone has any questions, we are open for it. Naveen sir?
Yes, I'm here. Audience, any questions? Anything you want to ask? So they are our own students. You can ask any questions. They are ready to answer. Alumni of Canara Engineering College who have developed their own small entrepreneur for the benefit of the people in Mangalore, in and around Mangalore. So if any particular topic you want to ask, you can ask.
Also, we'd like to add that this 3D printing and the developments in different areas also is bringing interdisciplinary cultures. That means the electronics engineer no more needs to have just the skill sets required to electronics. Having skill set related to CAD modeling also helps him, and that might become a integral requirement for him also if he if he has to work in a compact team, etc. At the same time, for a mechanical engineer, having the knowledge of electronics, the hands-on knowledge of electronics also helps. And this whatever open source movement in 3D printing has developed because of the people with such skills, who had skills of both things.
Good. Good.
So
now, how much
introducing such introducing such courses or workshops in colleges or as selective subjects, etc., might help in future days.
Okay, thank you. Good. So, how did you get this idea? My question: how did you get this idea that we have to start this startup or this type of small entrepreneurship ship idea? How did you get it? Where did you get this? And who all supported you in that journey, whichever short journey, but how you got the support?
Okay, if you have to answer in two parts, like what made us to start, uh, since around 2014-15 we were in touch with the maker community. Like there is people who are interested in building things irrespective of their technical background. There could be engineers also, designers also, etc. And a lot of startup related things are shared there. In Bangalore the community is more. In Mangalore there is no community at all, and so many events, like so many in around 2014-15, so many maker spaces started in India, like Woodbench project in Bangalore. Now there is one makerspace in Mangalore. In 2016 there was one started where I was associated also. So we were somehow connected with that community and that lane, and uh, so since we were connected and we were exposed to that, somehow there was a want to start something on our own also. But regards to what was the question, and that want only made us to work in startups instead of going to conventional industries, uh, to get an exposure in terms of the startup culture. Uh, because in working at a startup, a lot of things are involved, not just building a product or not just providing a service. A lot of things are involved. Lots of challenges come. Like if I when I joined as a hardware engineer in the startup, that mixed reality startup, I had there came a situation where I had to debug the website also. So the interdisciplinary skills and exposure to all such hurdles kind of makes you ready to take the plunge also. So regards to what made us to start the 3D printing startup is constant in communication with Suhas. He was completely in touch with the 3D printing, and I was had built the 3D printer, but was using it for the process more. And having communicated with many industry friends in the industry, somehow we thought starting up not a conventional services startup like CNC service providing something like that, but providing a platform for manufacturing kind of uh, can make into a good startup to scale in future. So that somehow convinced us. We also took the when we got the idea, we didn't just thought, okay, let's start. There are if anybody wants to start, at least in the student level, my suggestion would be that only, because would be that get some advisor, approach some uh, consultant. Like one institution which I can suggest is in IIM Bangalore, there is a entrepreneurship cell called NSRCEL, NS Raghavan Cell for Entrepreneurship Learning. There every week they have consultancy kind of opportunity for anybody who has an idea. If we have an idea, we can pitch to them, and they will kind of try to connect us to people who are into that field. They will kind of try to give us more views into that, uh, make us to look into that with different aspect. Because normally when we think we have to start a business, there is a possibility that we end up investing more without having much of an information regards to where our customer is, who is our customer, is there enough opportunity uh, for the service or product we are providing uh, in the direction we are looking at. There could be whole new market for the product also. So before starting, consulting somebody or speaking to as many people as possible is good. So we did that. And in setting up the process, in setting up the starting the startup, one of our friends' parents, father who was a CA, he has guided us throughout the process, registering, taking up the license, and what is necessary, what is not, etc. And even the industry associations in Mangalore, they have helped us to give us exposure to people, uh, connecting us to the potential people who are open to trying new things. That becomes a major advantage for a startup in the initial days. And also, one of the things which has happened in our life is the 3D printing has come to our life again and again. When we had built a 3D printer in college, then we left it. We had no idea what to do, so we just came out and we went with our career. Then Navin sir one day called us for taking a workshop in 3D printing in our college. And same thing happened again. And we ended up giving 3 to 3 workshops. So Naveen Kalal sir, we'd like to thank you for bringing the 3D printer back into our life, and also Canara Engineering College, where we have got lots of support from electronics and communication department also, and majorly mechanical department also in different aspects. Even though I am a electronics engineer, I was part of Baha. I'm a unofficial mechanical rated engineer, I can say. So this is part of why we started up. And also, I think I explained who and all helped us.
Thank you. Thank you once again, Suhas and Sumanth Shenoy. So, you have shared your website, and I hope some of the people who are there in the online, or who are there in this FDP, if they are willing to make use of these two persons, I'll be very happy. And they can go through this website, which we have posted in the chat box. So you'll get to much more details about their company and what they have started. It's a very small one-room company. Very nicely they have put it, and they are providing solutions. So all the best for you for joining, and all the best for your career also. So hoping you will get much more prosperous in your life. Okay. Thank you. Thank you, Suhas. Thank you, Sumanth. Okay.
Thank you, sir. Thank you, sir.
Okay. Welcome.